Hello students, in today's class we will be studying about law of conservation of momentum, equilibrium of a particle, friction in friction, frictional force, types of friction, laws of friction, methods of reducing friction, advantages and disadvantages of friction, circular motion and an important derivation of the expression for maximum speed of a car moving on a banked circular road. Let's state law of conservation of momentum. That is, total momentum of an isolated system remains constant, or when two or more bodies collide with each other, the total momentum of the bodies before collision is equal to the total momentum of the bodies after collision. Let us understand law of conservation of momentum in detail. Consider two bodies A and B with the initial momentum PA and PB respectively. Let these two bodies collide with each other at a time, that is, let dt be the time of collision. At the time of collision, body A exerts a force on a body B, that is FAB, and the body B exerts an equal amount of force on a body A, that is FBA. After the collision, they move with the momentum P-A and P-B. Now, according to the Newton's second law, FAB is equal to P-B minus PB by dt. That is, the rate of change of momentum of a body is directly proportional to the applied force. Now, for the body A, we'll write it FBA is equal to P-A minus PA divided by dt. Now, according to the Newton's third law, for every action there is an equal and opposite reaction. We can write FAB is equal to minus FBA. Now what happens from the two equation? P-B minus PB is equal to minus P-A minus PA. Now we can write the equation as P-A plus P-B is equal to PA plus PB. This shows that the total momentum of a body AB after collision is as same as the total momentum before collision. Here we'll see an example for the law of conservation of momentum, that is gun. When a bullet is fired from a gun, the gun recoils or moves back because the total momentum of a gun and the bullet before firing is zero. After firing, the bullet moves forward. The gun moves in the backward direction to conserve the momentum. So this is the example of law of conservation of momentum. I request you to list some more similar examples. Let's understand equilibrium of a particle. If two forces F1 and F2 act on a particle, equilibrium requires F1 is equal to minus F2. That is, the two forces on a particle must be equal and opposite. Equilibrium under three coherent forces like F1, F2 and F3 requires that the vector sum of the three forces is 0. Like F1 plus F2 plus F3 is equal to 0. So we can define the equilibrium of the particle is when a net external force on the particle is 0, then it is in the equilibrium. This means that particle either at rest or in uniform motion. Let's understand friction. Before going to understand this friction, we'll understand some basic concept, that is, when two bodies are kept in contact, they interact with each other through a contact force. The contact force arises due to an electromagnetic interaction between the molecules of the surface in contact. The contact force is resolved in two components. One is normal reaction and the other one is friction. So now we'll understand what is this friction. This friction is the property by virtue of which a force is created between two bodies in contact, which opposes the relative motion of one body with respect to the other is called friction. So next we'll understand what is this frictional force. The force which opposes the motion of a body over the other in contact with it is called frictional force. So the maximum frictional force depends on the nature of the bodies and the normal reaction between two bodies. It is independent of the area of the two bodies and their relative position. Further, we'll study the types of friction. There are two types of friction. The first one is static friction and the next one is kinetic friction. Let's study about the static friction. Frictional force when balances the applied force when a body is in the state of rest is called static friction. For example, consider a body on the floor. When the body is pushed with a small force does not move because the floor exerts a frictional force on the body which balances the applied force. So this is static friction. The second one is kinetic friction. It is also called as dynamic friction. So let's define this kinetic friction. When a body moves over the other, the force of friction acting between them is called as kinetic friction or dynamic friction. For example, consider a body X moving on the surface of Y. The kinetic friction acting on X due to Y will be opposite to the direction of the motion of X. This is called kinetic friction. Further, in kinetic friction, there are two types of friction. The first one is rolling friction. When a body rolls over the other body, then force of friction acting on them is called as rolling friction. The second one is sliding friction. When a body slides over the other body, then force of friction acting between them is called sliding friction. Let's understand limiting friction. The maximum static friction that a body can exert on the other body in contact with it is called limiting friction or a force of limiting friction. This limiting friction, we can write it as Fs, which is directly proportional to the normal reaction, that is capital R, between the two surfaces. We can write it as Fs is directly proportional to R, or else Fs is equal to mu s into R, where mu s is a constant called coefficient of static friction. Now we'll state laws of friction. The first one is the direction of the frictional force is always opposite to the direction of relative motion of one body over other. The second, the magnitude of the frictional force is directly proportional to the normal reaction between the two surfaces. Next one, magnitude of the frictional force depends upon the nature of the surface and their state of roughness. The last one is magnitude of the frictional force is independent of shape and area of the surface. Next, we'll study how this friction is reduced, like methods of reducing friction. The first is friction between two surfaces can be reduced by polishing them. Next is in jets, rockets, aeroplanes, and cars are given streamlined shape to reduce friction due to air resistance. Third one is use of lubricants like oil, grease, etc. reduces the friction in machines. Last, like by using ball bearings, friction in wheels of cycle can be minimized. Here are some of the advantages of friction. A matchstick is lighted due to friction. A nail or a screw can be fixed in wood only due to friction. Brakes of the vehicle works due to friction. When we walk, friction between the ground and the feet prevents us from slipping. Next comes disadvantages of friction. Machine requires extra power to overcome friction, hence their efficiency decreases. Friction between different parts of machine produces heat and causes damage in them. Let's derive the expression for maximum speed of a circular motion of a car on a banked road. Let's start. Let m be the mass of the car and small r be the radius of curvature of the curved road, which is banked at an angle theta, and on which the car is moving with the speed v, that is the velocity. Normal reaction, that is capital R, can be resolved into r cos theta and r sin theta. Frictional force F is resolved into F cos theta and F sin theta. Now from the figure we have r cos theta is equal to mg plus F sin theta. We consider this as equation 1. Next, r sin theta plus F cos theta is equal to mv square by r. We consider this as equation 2. Centripetal force is provided by the horizontal components of F and R in the figure, where F is the force of static friction. As we know, the velocity is maximum when the limiting friction, that is F, is equal to mu s R, as you already know about the limiting friction. Now we'll substitute the value of F in equation 1, that is r cos theta is equal to mg plus mu s r sin theta. Now rewriting the equation as r cos theta minus mu s r sin theta is equal to mg. Taking r as common, r in the brackets of cos theta minus mu s sin theta is equal to mg. Later we can write it as r is equal to mg by cos theta minus mu s sin theta. Now substituting the value of r and f in equation 2, we get it as mg by cos theta minus mu s sin theta into sin theta plus mu s cos theta is equal to mv square by r. Now taking v this side, v square is equal to sin theta plus mu s cos theta whole divided by cos theta minus mu s sin theta into rg. Dividing the numerator and the denominator by cos theta, we get it as v square is equal to tan theta plus mu s whole divided by 1 minus mu s tan theta into rg. Or we can write it as v is equal to square root of tan theta plus mu s by 1 minus mu s tan theta into rg. If we consider mu s to be 0, then v is equal to root of rg tan theta. So this is the required expression for maximum speed of a circular motion of a car on a banked road. So dear students, from this the chapter laws of motion completes. Thank you.